Welcome everyone to this week's Science News. Today we'll talk about the muon anomaly at Fermilab, say goodbye to LK99, hear from scientists who say that the sun is brighter than we thought, look at a new ion trap, talk about a cold blob, plans for a new space station, delay with NASA's trip to the moon, freeze rays, the smallest traffic light ever, and of course, the telephone will ring. Physicists at Fermilab in the United States have made a better measurement of the magnetic moment of the muon, and it confirms the anomaly they had previously measured. The muon is one of the particles in the standard model of particle physics. It's unstable and decays within a few microseconds. The muon has a magnetic moment that tells you how fast the particle spins in a magnetic field. Without quantum effects, the magnetic moment of the muon, usually denoted G, should be 2. Physicists are interested in the quantum contribution. That's often just called the G-2. The G-2 of the muon can be predicted from the standard model. Already in 2001, an experiment at Brookhaven found that the measured value of the muon G-2 deviates from that predicted by the standard model, though it wasn't a huge deviation. In 2021, a follow-up experiment at Fermilab confirmed the earlier result, raising the statistical significance to 4.2 sigma. These experiments are basically rings of magnets in which the muons go in circles until they decay, which is a good metaphor for life in general. One then measures the momentum of the decay products, from which one can infer the G-2. The additional data that the Fermilab group has collected since the headlines 2 years ago have now decreased the uncertainty of the measurement and increased the significance to 5 sigma. That's less than a 1 in 3 million chance of it being a fluctuation. This discrepancy between the prediction from the standard model and the data could mean that something is missing in the standard model, maybe new particles or other new physics. This is why you might have seen headlines this week about fifth forces, which seems to be the term that the media has adopted for new physics. If you wonder what a fifth force is, I made a video about this last year. However, in the past few years, there have been several papers saying that something might be amiss with the prediction from the standard model instead. Calculating the magnetic moment to the required high precision is difficult, and at the moment, different methods give somewhat different results. And you don't need to know much maths to see that if 2 ways to calculate the same thing give different results, that's not good. So the new data tell us that it's very unlikely the tension comes from a measurement error. It's almost certainly a problem with the theory, and that could mean new physics or a problem with the calculation. I guess the fifth force headlines will go around in circles a few more times before they decay. The claim of the supposed room temperature superconductor LK99 from the Korean group has been pretty much laid to rest. About a dozen or so replication experiments have found that while the material has complicated magnetic properties, it's not superconducting at room temperature. There have been some claims that it's superconducting around 100 Kelvin, but even if that was the case, it wouldn't be particularly remarkable. Nevertheless, I think this has been a very interesting episode, and while it's not going to change the world, it'll without doubt give rise to a lot of follow-up work to see if related materials may have the desired property after all. In brief, I'm sorry, but the revolution has been postponed. Physicists at Michigan State University have looked at the sun and found that it emits gamma rays of energies up to several tera-electron volts. That's almost as much as the Large Hadron Collider pumps into proton collisions. Gamma rays are electromagnetic radiation, just like light in the visible spectrum, but with much higher energy or shorter wavelength, respectively. The sunlight that we see with our own eyes has an energy of about 1 electron volt per photon. The gamma rays they observed coming from the sun have about 1 trillion electron volts. That's even higher energies than X-rays. NASA's Fermi Space Telescope had already collected data on gamma-ray emissions from the Sun up to about 0.4 tera-electron volt. This new measurement now comes from the high-altitude Waterschrankhof Observatory in Mexico and continues to even higher energies. At this observatory, they don't measure gamma rays directly, but they measure the radiation that's created when these gamma rays hit the upper atmosphere. They then create a particle shower the same way that cosmic rays do, and these particles can be measured when they interact with the water in these big tanks. They can figure out which ones came from the sun by their timing and arrival direction. In the new paper now, the team reports on data they collected during 6 years. They say they found a signal of gamma rays from the sun at energies exceeding a teraelectron volt with more than 6 sigma significance. Basically, this means they're very sure it's real. In this figure, the red band is where they say the gamma ray emissions from the sun are. The horizontal axis is the energy, and the vertical axis is, loosely speaking, a measure for the number of particles. The blue band is an extrapolation of the spectrum from Fermi. As you can see, it would be higher. The scientists say that's because Fermi's measurements were during a solar minimum. This means that, somewhat counterintuitively, the emissions of gamma rays seem to be higher during a minimum. Just exactly why that is, no one knows. The gamma rays are believed to mostly be created above the surface of the sun when cosmic rays scatter there. But no one expected that the energies would be so high. Though I'm pretty sure my gamma ray emissions are also higher during a minimum. Sandia National Laboratories has presented their newest advance in the area of quantum computing, the Enchilada trap. It's a type of ion trap, a device that's used for quantum computing. Ion traps are little cavities on microchips that hold charged atoms. They are one way to create qubits, the building blocks of quantum computers. Sandia's previous ion trap, the Roadrunner, could accommodate up to 32 qubits. The Enchilada trap can house an impressive 200. That isn't quite as much as the chip that IBM recently announced with 400 superconducting qubits, but it's decent. Two things that are worth keeping in mind. First, commercial applications of quantum computing will need about 1 million or so qubits, so there's some way to go. Second, the number of qubits isn't the problem. You can just keep on lumping them together. The problem is to lump them together and still use them. I don't know if you've noticed, but I've noticed that while IBM announced their 400-qubit chip at the end of last year, until now they haven't told anyone what it can do. I find that very interesting. There's a cold blob in the Atlantic Ocean, and I'm not talking about a dead fish. The cold blob is an area of the North Atlantic Ocean that's getting colder, even while the rest of the world's oceans get warmer. A new study now suggests that changes in wind patterns are to blame, at least partly. The cold blob has cooled by about 0.5 degree Celsius, while the rest of the world has warmed by about 1.5 degrees. This strange observation has previously been attributed to changes in the ocean circulation. But the authors of the new paper say that the wind also plays a role. Over the Atlantic Ocean, we have something called the North Atlantic Oscillation. That's a recurring pressure pattern. The wind over the Atlantic Ocean usually blows west to east, and the North Atlantic Oscillation strengthens it and pushes it north. This blows away warm air and cools the ocean like if you blow over a cup of hot water. There's another set of pressure patterns called the East Atlantic pattern that counteracts this effect, but altogether the scientists say the cooling effect wins. The major message of the paper, I think, is that one really has to look at the ocean circulation and the atmospheric circulation together. Though if this was cosmology, someone would claim the cold blobs caused by entanglement with a parallel universe. I've read there's a lab in the United States working on a freeze ray. Naturally, I had to find out what this was all about. The first thing I learned is that the freeze ray is a plasma beam. Plasma is a state of matter in which the electrons are not bound to atoms. That matter takes the form of plasma doesn't necessarily mean it's hot, the same way that matter taking the form of a gas doesn't necessarily mean it's hot. It really depends on the type of matter. And cooling stuff by shooting something at it isn't as weird as it sounds. Laser cooling, for example, does the same thing. For that, you shoot a laser at a bunch of atoms so that they absorb and re-emit the light, but so that on average they lose energy. A similar thing seems to be going on for these plasma beams. They help some materials lose energy. For their freeze ray, the researchers use what's called an atmospheric plasma beam. That's basically a sustained discharge in air that plasmarizes molecules. If plasmarize isn't a word, I really think it should be. They initiate this discharge with ionized helium. So they push the helium through the air with high voltage, and that creates a lot of other ionized molecules. That's the atmospheric plasma beam. They aimed this beam at a gold-plated surface. When the plasma struck the surface, the resulting interaction made the surface colder than it was before. While the effect only lasted a few microseconds, the researchers think with more work they can create longer-lasting effects. Before you get overexcited though, it turns out that this cooling only works for the surfaces of certain materials and it cools by a few degrees Kelvin at most. So I'm afraid you won't get to freeze someone to death anytime soon. However, this method might come in handy to cool devices in outer space. Also, the US Air Force has given the lab $750,000 to work on its freeze ray, so maybe they know something we don't. The successor of the International Space Station, Starlab, is moving to the next phase. Voyager Space and Airbus have agreed to go ahead with their plans to build a commercial space station that'll succeed the International Space Station ISS. While the ISS has served us well, it's not the youngest, and NASA plans to decommission and deorbit it by 2031. Voyager got $160 million for the Starlab project back in 2021, when NASA started to look at replacing the ISS. It's about time because China already has its space station Tiangong in low Earth orbit, and India plans to launch one in 2035. It'll be a while before we get details about Starlab, but we do know a couple of things. To begin with, NASA is to be the lead tenant, but other nations' space agencies may also use it as a base. The station will be continuously crewed, and it'll host several research labs to conduct experiments in biology, material science, physics, and agriculture. Hopefully, growing potatoes on Starlab will be easier than Matt Damon found it to be on Mars. At least it should be comfy, because Voyager and Airbus have partnered with the hotel company Hilton to make sure everyone has a pleasant stay. I imagine it'll go like this. Hello, I don't mean to complain, but there's no gravity in my room. By the way, if you prefer reading or listening to watching videos, you can now also find us on Substack at sciencewtg.substack.com and on Spotify and many other podcast apps under the name Science with Sabine. Donald Trump planned to bring Americans back to the moon by 2024, but NASA had to postpone the landing, and at the moment it's unclear when they'll manage to make it happen. A senior official from NASA hinted in a press conference last week that the Artemis program, whose third mission was supposed to land on the moon, is facing significant delays, particularly with the lunar lander from SpaceX. NASA's Artemis program is a series of progressively challenging missions that might one day establish a permanently manned base on the moon. Artemis 1 was originally scheduled for late 2021, but launched with a year delay in November 2022. It successfully sent a spacecraft around the moon. Artemis 2 was originally planned for August 2023, but it's now tentatively scheduled for late 2024. This second mission should also fly around the moon, but this time with a crew on board. The plan is that Artemis 3 would land on the moon. This mission was originally scheduled for 2024, but it was rescheduled to late 2025. Now it looks like it might get even later. The success of Artemis 3 hinges on the lunar lander that would safely transport astronauts from the spaceship to the surface of the moon and back. It was supposed to be delivered by Elon Musk's company SpaceX. The lander is a variant of the SpaceX Starship vehicle, which is a reusable spacecraft that can carry up to 100 tons of cargo. However, a test for the Starship in April did not work out as planned. The two stages failed to properly separate, and the company had to detonate the vehicle for safety reasons less than 5 minutes after start. Jim Free, NASA's associate administrator, explained that the agency is now considering the possibility of altering the scope of the mission. I think that's a good attitude. I might try that myself. It's not like I'm late with my tax return. I've just altered the scope of the mission. Hello? Hi, Albert. Space and time news. Yes, we do have space and time news. A company has shipped wine into outer space and says that it ages faster. They're now planning to commercialize the idea. No, I think it's not relativity, it's chemistry. That's the thing with the molecules. I'm very tempted by an overpriced bottle of astronaut envy, but I think I'll hold out for the Moon Cheese Deluxe. As Buzz Aldrin famously said, one small sip for a man, one giant cheese for mankind. Thanks for calling in. According to a new study out of Israel, scientists may have found a way to make nanocrystals switch colors. The display you currently use probably uses liquid crystals, but some large displays you might see for advertisements already use nanocrystals. Nanocrystals are kind of like tiny LEDs. They're normally used together with liquid crystals to tune brightness. At the moment, though, for getting different colors in a nanocrystal display, you need several different crystals. It would be much more convenient if we could use one type but switch their color. The researchers now claim they found a solution by building a new molecule out of 2 nanocrystals. An electric field can then change the arrangement of the new molecules, and that changes the color that they emit. Since this change is caused by electric fields, it happens very quickly, in just about a nanosecond, and the brightness doesn't suffer. They use as an example the switch from green to red, so a teeny tiny traffic light basically telling photons when they're allowed to walk. It can be hard to keep an overview on what's going on in science. If you also sometimes feel it's a little bit overwhelming, have a look at Nautilus, who've been sponsoring this video. Nautilus is a science magazine that has a digital and a print version, and it's just a pleasure to read. This, for example, is a recent special issue on the ocean. Have a look. It's a really high-quality print with beautiful graphics and very easy on the eye. It's just exactly what I need on a Sunday afternoon in the garden. What I particularly like about Nautilus is that they cover all areas of science, from astronomy to economics, history, neuroscience to philosophy and physics. They pick the most relevant topics that you need to know about and really put a lot of effort into crafting their articles well. I've written several contributions for Nautilus myself about quantum gravity and black holes and how to make sense of quantum mechanics and so on. But more importantly, they keep me well informed. I learned from this recent article, for example, that telephone scams with deep-faked voices are already much more common than I thought. You can join Nautilus as a digital-only member or get a print subscription. In addition to full access to all the stories in Nautilus, members receive benefits like priority access to events, exclusive products and product discounts. And of course, we have a special offer for our viewers. If you use our custom link note.us/Sabine, you'll get 15% off your membership subscription. So go and check this out. Thanks for watching. See you next week.